Hello, I'm Chris Barclay, the product manager for Wavelength. Thank you for joining me to discuss how Wavelength enables developers to deliver applications that require ultra-low latency to users and devices on 5G mobile networks. We launched Wavelength on August 6th on Verizon's 5G network, allowing developers to build ultra-low latency applications for mobile devices in Boston and the San Francisco Bay Area, and will be expanding to more locations and carriers later this year. In today's webinar, I'll describe why we built Wavelength, use cases for why developers are using Wavelength, dive into the developer experience, and finish with some Q&A. AWS has dozens of regions that enable developers to build applications that provide low latency globally, and a comprehensive set of solutions for building edge applications. Wavelength, Outposts, and Local Zones all bring AWS services to more places with the same experience and benefits that developers are used to. Wavelength, however, is unique in that it is designed to enable developers to build ultra-low latency applications by extending AWS infrastructure, services, APIs, and tools into 5G networks. Developers can take existing applications and extend them to Wavelength zones, or build new applications using AWS services like EC2 and EKS. Why should you care about low latency access to compute? Well, we all encounter examples of latency in our daily lives, such as an entrance to a congested expressway. And even when there's tons of bandwidth, such as open lanes on a highway, the number of hops or distance traveled still matters. Emerging interactive applications like game streaming, industrial automation, and connected vehicles require more compute and data processing. To solve these problems, developers told us they wanted to bring the cloud to the device. We saw an opportunity to combine the benefits developers have come to love about the AWS cloud, including a broad set of services, pay-as-you-go pricing, and elasticity, with the ultra-low latencies and high bandwidth of 5G to enable developers to create truly novel experiences. Wavelength brings AWS services to the edge of the 5G network, minimizing the latency to connect to an application from a mobile device. These emerging interactive applications, like game streaming and virtual reality, require ultra-low latencies to end users and devices, and consistent quality of service on data flows to deliver the desired experience. The 5G network is up to 20 times faster than 4G and can be used to shrink network latency. However, even with the arrival of 5G, mobile devices still had to cross multiple network hops when connecting to an application over the internet. Before Wavelength, application traffic had to travel from a device to a cell tower, to metro aggregation sites, and to the internet before it could access resources running in AWS. These network hops could result in latencies of tens of additional milliseconds. Previously, this prevented developers from realizing the full potential of 5G to address low latency use cases. In addition, with Wavelength at the 5G edge, we can now meet the needs of applications that need data processing to happen closer to the device. Using Wavelength makes it possible to avoid buffering on uplinks and downlinks, which is particularly useful for large objects and streaming video data. Wavelength also saves storage and battery power because the data does not need to stay or be processed on the device. For example, data from video cameras and mobile IoT devices are good candidates to be pushed to the edge for fast local processing and to reduce the quantity of data that is sent across the internet. One class of applications with these requirements is inference at the edge, such as a smart factory where sensors can detect quality problems in healthcare for doctor assistance during procedures. One challenge with machine learning applications is system responsiveness, which requires the inference processing application to be close to the end user. This used to mean the device needed expensive and power-hungry processors. Additionally, if you needed to update your machine learning model, you had to push out an update to all the devices running your application. Now, 5G and Wavelength provide significantly lower latency and much more bandwidth compared to previous generation mobile networks, allowing you to use the cloud as an extension of your mobile device. For edge applications, this implies you can actually perform inference processing, even with HD video in a Wavelength zone, with real-time responsiveness to the mobile device. By moving the inference processing to the Wavelength zone, you reduce power consumption and battery drain on the mobile device. And additionally, you can simplify application updates. If you need to make a change to your training model, you simply update your servers in the Wavelength Zone instead of having to ship a new version to all the devices running your code. There are many use cases where Wavelength can help. A few highlighted in our launch include healthcare, where AI/ML-driven video analytics and image matching solutions help doctors speed up diagnostics of observed conditions, such as recognizing polyps during colonoscopies. The video streams from medical devices are processed in a Wavelength Zone, and the response is returned to the medical device for the surgeon to use. Connected cars enable capabilities such as improved road safety. Low latency access to compute infrastructure is needed to run data processing and analytics to monitor data from sensors for secure connectivity, in-car telematics, and safety warnings. And third, Wavelength also provides the ultra-low latency needed to live stream high-resolution video and high-fidelity audio, as well as to embed interactive experience into the live video streams. Additionally, video analytics provide the ability to generate real-time statistics that can enhance live event experiences. Wavelength provides 4 benefits. First, Wavelength brings AWS services to the edge of the 5G network, minimizing the latency to connect to an application from a 5G mobile device. Application traffic can reach application servers running in Wavelength without leaving the mobile network. This prevents the latency that would result from multiple hops to the internet and enables customers to take full advantage of the advancements of 5G. Customers can now deliver immersive experiences like game streaming to end users on mobile devices. Robots, cars, and other smart devices can make complex decisions that require more computing power than is available on the small form factor. Bringing AWS closer to end users and devices unlocks these opportunities. Second, you deploy your application to Wavelength Zones, AWS infrastructure deployments that embed AWS compute and storage services within telecommunication providers' data centers at the edge of the 5G network. Wavelength Zones deliver a consistent developer experience across multiple 5G networks around the world, allowing you to build ultra-low latency applications using the same familiar AWS services, APIs, tools, and functionality you already use today. You can deploy portions of your cloud-based applications requiring ultra-low latency to Wavelength and then connect seamlessly to the rest of your application and services running in AWS. Third, with Wavelength, you get capacity close to your end users and data, along with AWS benefits such as no capital costs, pay-as-you-go pricing, and the ability to scale up and down on demand. Finally, AWS Regions, Local Zones, and Wavelength expand AWS to deliver ultra-low latency to more locations around the world. You get those same benefits whether end users connect over the internet or mobile networks in the Americas, Europe, Japan, Korea, and more locations to come. How does Wavelength deliver these benefits? Unlike previous generations of mobile networks, which were just about increasing bandwidth, 5G is about a lot more. 5G provides benefits of more bandwidth and lower latency from the mobile device to the compute running in the Wavelength Zone. It achieves this through advances in wireless technologies. Upper bands of the spectrum are being used to deliver high bandwidth. Wider spectrum band equates to higher bandwidth. Then, new antenna technology is being developed that supports more mobile devices at high bandwidth. Later, network functions will enable the network to be virtualized, providing flexibility of deploying components in various parts of the network and dynamically adjusting the network for what each component needs. Latencies of applications deployed to AWS regions depends on where the users are, where the regions are, and the specific paths traversed to reach the applications in the regions. The latency typically is on the order of tens of milliseconds if you look across a broad population of mobile users. With compute instances running at a site embedded in the mobile network, this network distance is reduced. Since the network path traversed is shorter and the quality of service is highly controlled in mobile networks, the latency is predictable and has less jitter, which is important for applications such as gaming and others that require tight synchronization across users. In addition, use cases with high data transfer can process it earlier in the network path, reducing the network bandwidth used in backhaul networks. Now that we've described why we built Wavelength, we'll dive into the developer experience. With Wavelength, you can build applications with services such as Amazon EC2, EBS, VPC, and Amazon ECS and EKS for containers. All AWS tools work as well. API calls will automatically be logged via CloudTrail. Developers can continue to use familiar and powerful AWS services to manage, secure, and scale their applications, like CloudFormation, Identity and Access Management, and autoscaling. And you can access AWS services running in the region, such as DynamoDB, S3, and others, in the same way as you do today in the cloud. Let's look at some of the concepts of wavelength zones that we can see from the Describe Availability Zone API call. First, you need to be opted into Wavelength to use it. The zone name is passed into APIs like Create Subnet, just like availability zones today. The group name is used to refer to groups of wavelength zones for a particular carrier. This group is Verizon zones in the Northern Virginia region. You can also see the network border group, which you use to allocate IP addresses on the carrier's network to EIPs to be used within EC2 instances. Applications built on Wavelength start with a VPC, just like you use for applications on AWS today. Wavelength zones use existing ADC concepts. After you create a VPC, you can create subnets in a wavelength zone along with route tables, security groups, and other resources as you're familiar with. EC2 instances and wavelength zones are created in a subnet in the VPC and use the VPC's IP address range. This enables your application components in wavelength zones to use a secure and high bandwidth connection to access all the resources in the region. As we see here in the console, you can create a subnet in a wavelength zone just like other subnets and specify the VPC and the CIDR range for the subnet. In this example, you can see that instance Y in the wavelength zone can connect to instances B, D, and Z over the local VPC network. Existing concepts like transit gateways and VPC peering continue to work, and you can use endpoints for services like S3. With Wavelength, we have introduced a carrier gateway to route the traffic between the wavelength zone and a carrier network in a specific location, as well as outbound traffic to the internet. The carrier gateway provides connectivity between your wavelength zone and the telecommunication carrier's network, including mobile devices on that network. The carrier gateway performs NAT for the EC2 instance's private IP addresses to the carrier IP addresses from a pool that is assigned to the network border group. The carrier gateway NAT function is similar to how an internet gateway functions in an AWS region. This shows a screenshot of creating a carrier gateway for your VPC in the console. You just specify your VPC and what subnets you want to use the carrier gateway, and the wizard will create the routing rules for you. Now that we've described how Wavelength uses the same VPC constructs as you're used to in the regions, let's describe how data flows from EC2 instances and wavelength zones. EC2 instances and subnets and wavelength zones can connect to EC2 instances and subnets and availability zones over a highly available and high bandwidth link using the private IP addresses in the VPC. This makes it easy to have some parts of your application run in the region and other parts run in wavelength zones. In addition to VPC private IP addresses, you can put a carrier IP address on each EC2 instance. The carrier IP address is on the carrier's network in the specific location. For example, in the Boston wavelength zone, it is on Verizon's network in Boston. Connectivity to the mobile network goes through the carrier gateway, allowing a device on the carrier network to connect directly to an EC2 instance, subject to your security group rules. The carrier gateway also provides egress to the internet, so you can connect to internet resources like GitHub or to get operating system updates. Note that this path is for internet egress and response. Wavelength zones are not accessible from the internet. There are two ways to access AWS Service Endpoints: over the internet or using VPC endpoints. VPC endpoints provide connectivity that does not require EC2 instances to have outbound internet access. Instead, you use the private DNS name as shown here. This illustrates the two paths to connect with an AWS service like S3, either over the internet or by using the S3 VPC endpoint. And here's an example of a VPC route table in a wavelength zone. You can see the S3 endpoint listed as well as the default routes for the carrier gateway and local VPC traffic. When you're constructing applications, there are a few things to think about. Wavelength zones are designed for applications that need to connect to compute from devices on 5G networks with ultra-low latency, and applications that need high and consistent data rates from devices on 5G networks to compute in a wavelength zone. AWS recommends you architect the edge applications in a hub-and-spoke model, with the region providing the most scalable, resilient, and cost-effective options for components. You can run the application components that are less latency sensitive or that need to persist state, such as databases or training ML models and backend worker processes in the region. You can then run application components that are latency sensitive in the wavelength zones. As an example of how these recommendations are used in practice, you can see that Amazon ECS has its APIs and control plane in the region. You can run ECS container instances in availability zones as well as in the wavelength zones. A typical way to set this up is to create an autoscaling group in the wavelength zone that registers the container instances with an ECS cluster, and then manage your containerized applications in the zone. Each of the container instances registers itself with the ECS control plane. Let's put this all together to see an actual example of a customer application deployment. A gaming application typically has a game server that runs the game session and does a lot of the real-time video rendering. These are latency sensitive. Then there are services that maintain the state of the player, which might need to be recovered if the game is paused, and these are not latency sensitive. And there's the game image that is typically stored in S3 and AWS Regions. In such a scenario, the developer would determine where the end users are geographically and decide where they ought to deploy the game servers. This could be in one or many wavelength zones. The developer would create a VPC and launch the game server in the wavelength zone and deploy the state service in the region. The image download would happen from S3. Now, with the game server running in the wavelength zone, a mobile device requesting to use this would first reach a service discovery in the region. The service discovery will know all of the EC2 instances of the game servers running across the wavelength zones and would determine the best instance of the server to connect to for the lowest latency. The device would then connect to the application over the 5G network through the carrier gateway. So as you can see, wavelength zones provide compute at the edge with the developer experience the same as AWS Regions, as you're still using EC2 instances and VPCs, but at the same time, gives you flexibility of constructing applications that use 5G networks in the regions. To simplify the provisioning process, create resources using a tool like CloudFormation. This allows you to templatize what is created in each new zone, such as subnets, route tables, auto-scaling groups, and so on, to ensure consistency. The new carrier gateway resource can be used during the VPC and subnet creation process. Then you create your application resources in the subnets, such as auto-scaling groups. You can deploy your template using CloudFormation in the Oregon and Northern Virginia regions. This makes it easy to expand your application to new wavelength zones as they launch. Now let's look at how ShotTracker created an application that uses wavelength. Sports fans appreciate real-time statistics to track the live game. Leagues have been instrumenting players and equipment to enable more data that can be used to create custom statistics. This volume of data can create insights, but to make sure it's live with the game, it needs to be processed with ultra-low latency. In the past, this meant it needed to be processed locally. Now this information can be sent to wavelength for processing and provided to fans directly, as well as to teams and broadcasters. The data can be sent to the region to be distributed to other applications and archived in long-term storage. Let's hear directly from the ShotTracker team what they've done.
Hi, my name is Davian Ross, and I'm one of the founders and president of DD Sports, and our basketball product is called Shot Tracker. Shot Tracker is a sensor-based technology that tracks statistics and analytics, providing real-time data to coaches, broadcast partners, fans, and players, all with sub-second latency. Basketball is constant activity up and down. Latency is so critical. One thing that we're doing that's really exciting is demoing our Shot Tracker technology over Verizon 5G and AWS Wavelength. This allows us to see the delta between the traditional process, which is 4G, and this accelerated, amplified process that utilizes both 5G and MEC. You can distinctly see the difference in the speed of ball movement. When I think about what 5G and edge computing can do, I think about coaches. I think about them getting access to this video and data anywhere in the facility. It may be in the locker room at halftime or sitting on the bench during the game, all delivered in real time. When you think about being able to take this data and incorporate it into the broadcast, latency is even more important. We're really excited about what 5G and MEC will provide to the market. We've been waiting on this for so long, and the time is now. It's finally here. And it will revolutionize the fan experience, the viewing experience, and how we consume data in sports for the rest of our lives.
We certainly appreciate Shot Tracker providing that customer testimonial. Thank you for attending the Wavelength webinar. Now I'd like to open it up for some Q&A.